This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 122. We talk about modeling mixing and catch up on news and events in the world of Ansys. Hi there, everybody. My name is Eric Miller, and I want to welcome you to our latest episode of the All Things Ansys podcast. I'm one of the owners here at PADT, and the busy summer continues. I'm actually in my hotel room near the Albuquerque airport at the Albuquerque Hilton Garden Inn. And I'm in town for the New Mexico Tech Council's New Mexico Technology Summit. That was Thursday and Friday, just finished up. And I'm going to be going to the 25th anniversary for the Sandia Tech Park, which is where we have an office that's right off Sandia National Labs, Kirtland Air Force Base right there. A lot of fun. While I was at the Tech Summit, I was able to talk about digital twins. Great conversation, both during the talk and then questions and answers afterwards. A lot of people came by the PADT booth, and we talked quite a bit about what it is and what the buzzwords are. And, as simulation people, we've been creating what many people call digital twin our whole careers, but it's got a much bigger meaning now. So kind of a fun topic to talk about. And I'm looking forward to meeting some customers and fellow leasees at the tech park on Tuesday. Also, as a side note, I took a day trip to Santa Fe. First time going to Meow Wolf. It was a lot of fun. And also saw some George O'Keeffe Museum and had some good New Mexico food and kind of wandered around downtown Santa Fe. So if you've never been to Santa Fe, I highly recommend it. I even, the nerd in me wanted to take the train from Albuquerque to Santa Fe. They've got a commuter train that runs even on the weekends. So I did that, and that was a lot of fun as well. So having a good time here in New Mexico. And a shout out to any listeners who live here in the land of enchantment. So, now, I did enjoy a margarita with my carne adobado last night, and to be honest, it was not well mixed. The alcohol was too heavy at the bottom, and the lime juice too strong at the top. Which brings us to our discussion for this episode, mixing with Ansys tools. That may be the weakest segue we have ever done on this podcast, but it actually is what happened. I was sitting there twirling my ice with my finger, and I thought about this discussion that we had recorded about a week ago, and it really does fit the real world often. Because mixing is an important step in many processes in many industries. And we kind of talk about that in the interview, that back in the day, most mixing problems were too complex to model with simulation. And that's just no longer true. I could even probably model that margarita mixing with the ice cubes. We got better computers, better models, better meshing, and now even complicated multi-phase problems can deliver useful information in a timely manner with Ansys software. So let's have a chat with Daniel to learn a little bit more. I want to welcome Daniel Chaparro to a discussion about a topic that I'm learning a lot about recently, which is modeling of mixing with CFD tools. So, Daniel, thanks for joining us.
Thanks for having me, Eric.
Yeah. So mixing is one of those things that I think about, and I think I know what it is, but when I was getting ready for this podcast, I realized I really didn't know what it was. So why don't we start with kind of a description of what do we mean when we say that we're simulating mixing? When we're talking about fluids, air and liquid and everything in between, or gas and liquids and everything in between, what do we really mean by mixing?
Sure. Typically, what we mean is we have dissimilar materials. They could be different phases or even both liquids or two gases. And the idea is that you want to design a system where you mix them and you end up with something that's more homogeneous, right? Like I think I've given this example before, you're making coffee and you start with, your coffee and your milk, you mix them with your spoon and you get something that's very homogeneous that you like to drink, right? You don't like to drink coffee on its own, probably not milk on its own either. So.
Yeah, right. And I think a lot of people are like me, is sometimes I just add the milk to see the mixing. It's kind of cool. So kind of fun. So this is used in a lot of different industries, right?
Yeah, we see folks in the pharmaceutical industry, oil and gas industry. Anytime that you are, mass producing mixtures, right? So when you're trying to combine different chemicals together into one solution.
And then how is the mixing done? I because of your example, I immediately think of a mechanical spoon, like a stirring device in a vat. But what kind of physically, how do we do the mixing? Do we jet stuff in? Do we stir it with an agitator? What does that actually look like in all those different cases?
Yeah. Typically, you rely on injecting from two different locations. Once it's in a vessel, in a mix tank, you tend to use one or several agitators, or kind of these propeller-looking devices that mix the different materials within the mix tank.
Okay, cool.
Yep.
Cool. So I'm visualizing that. So let's move over to simulation. So first of all, which Ansys tool do we use the most for this? It can be rotating machinery, so I assume there's some CFX maybe, but is it mostly Fluent?
Well, it turns out that Fluent has the most kind of advanced models when it comes to modeling chemistry and different turbulence models, etc. So you can definitely do a lot more advanced things in Fluent, but CFX obviously is really good at rotating machinery, and we can model that physics in CFX as well. It's just most people are moving towards Fluent these days.
So we model the fluid region and the mechanical region. We can do that whole moving mesh thing.
Yeah, we can model moving reference frames or sliding meshes within Fluent, so depending on the level of accuracy that you need. Yeah.
So one thing that seems kind of important is, and you kind of alluded to it, is the chemical reaction stuff. So we're not just saying that we've got milk and flavor colored coffee flavored water. We actually may have some chemical reactions taking place. Is that something we can model? And if so, how do we do that?
Yeah, not everybody needs to model that, but we certainly can. We can model, finite rate kinetics. So you can define your Arrhenius equation, and you can track species of different, around the mix tank. And as they mix, you can predict the rate of reaction, and therefore the products that come from that reaction as well. So yeah, so we can certainly do that too, and we can even go a step further. Sometimes folks want to do the electrochemistry part of it too.
Okay.
So you have electrodes in your mix tank, and we can couple that physics as well. So all within Fluent.
All within Fluent. Very cool. Very cool. And these things are popping in my head as I think about different. I'm going back a little bit to high school and college chemistry class, but what about precipitant? Is that something we can do and say that when we do this mixing, we're going to get some solids to come out? Is that can we dissolve solids? Is that capable as well?
Yeah, we do. So you're free to kind of define your reaction as you wish. So, and then the phase transfer from like a solid to a liquid, we can also model that. Yeah.
Okay. And that's really cool. So very, very sophisticated. So what's the biggest challenge from a simulation standpoint in setting up one of these models? Is it material properties? Is it geometry? Is it meshing? What's the big thing that users need to know about before they get into it?
Yeah, like what really kind of makes a good mixing simulation is the multi phase modeling that you choose. So we can go as simple as just tracking species, all the way up to kind of this Eulerian workflow where you can track the momentum transfer between different phases. So, and that those tend to be transient simulations. So, so generally speaking, they take a longer time to run. So that becomes a challenge. So being able to have like the hardware to run these simulations for however long it takes to mix two things, right? That's sometimes folks need to know how long do I need to have two things mixing before I get a homogeneous solution. So yeah, so that's inherently a transient simulation.
True. You mentioned hardware. I guess the answer to my question of what kind of hardware do you need to do mixing is probably it depends on the problem. But is this like more computationally intense than most CFD or kind of normal? And then if you got a big problem with a lot of elements and a long transient, should invest in parallel. Where does it kind of lay in that spectrum?
Yeah, it would be somewhere in the middle. Obviously, it's not like an external flow problem where you have 60 million elements and you're running for months at a time.
Right.
But it is something probably I would recommend more than just your standard workstation, again, because it's multi-phase, which means you're solving more equations.
Okay.
And it's transient, which means you're running it for longer. So if you have a cluster, or if you have the ability to solve on the cloud, I think this is a very good candidate for those choices.
Yeah, it might be a good one to take a look at Ansys Cloud on, or one of the other cloud providers to get a little bit better return on your investment on the speed there. So you did kind of we talked about chemical stuff. What role does, again, thinking back to my stirring in chemistry class, what role does turbulence play? I would imagine it's kind of significant, and do we have tools for that? I mean, where is turbulence in the fluid world these days? It seems like it's a lot better than it was when I first got exposed to it years and years and years ago.
Yeah, I mean, there's the latest and greatest kind of turbulence models in Fluent are these hybrid models where you don't need to resolve the smallest scales of turbulence everywhere, and so the model can detect where it can switch from Reynolds averaged Navier-Stokes equations to small scale turbulence modeling. So that's certainly something we can leverage here. We can also leverage how the turbulence affects the chemistry. So this turbulence and chemistry interaction. So it's not just as simple as yeah. So if you need to know that the model, you can basically hook the reaction rate not just to the chemical, stoichiometric equations, but also the amount of mixing going on in the turbulence and how that enhances the rate
the amount
of
of energy coming from the turbulence. Yeah. Interesting. Okay. And then the other thing that I always think about when I think CFD is meshing, and I think the fluent mesh has come a very long way, and these can be relatively simple containers, or they can be really complicated containers where the mixing is built into the geometry and as things flow through. Is the meshing gotten a lot easier and not as big of a challenge anymore? And how sensitive is the solution to the mesh quality?
Yeah, no, fluent meshing has definitely come a long way. We can create a high quality mesh with very little user input, very little manual kind of tweaking of the mesh and things like that. And they'll typically be, your agitator is probably the most complicated feature within your mix tank, and then you also have baffles and other features like that. But
that was a term I was trying to think of, baffles. Yeah, to get things to kind of trip over each other and mix together. Yeah.
Yeah. So I mean, I think it's critical to get the mesh around the agitator correctly, and then that's really the biggest challenge meshing wise. Fluent meshing really does a great job of giving you some good defaults, and then you can tweak from there.
Very good. Excellent. So if someone is thinking about doing some mixing, any advice you'd give them, other than your standard of, crawl, walk, run, and get your problem working on a small case before you do the big case? Anything else you'd pass along to them before they get started?
Well, I think I would point folks to the Ansys Learning Hub. So for those folks who don't know what that is, it's kind of the Ansys online university. And there's a whole learning room, we call it, with tutorials and best practice documents for mixing applications. So I would start with one of those. Find the one that's most similar to your application. There's, some folks are looking at mixing solids and liquids, and, solid suspension. Some folks are looking at two liquids and multiple agitators. So find one that's most similar to your application and kind of more or less translate that setup to yours. And I think that's the best chance of success.
That's really good. Yeah, so that's if you don't know how to get access to that, reach out to whoever in your company is your contact with Ansys, or reach out to Ansys support. Or actually, you can just read an article on our blog we just had about all the different user websites that are available out there for Ansys users that Ansys provides. Just the Ansys provided websites, and one of them is the Learning Hub. So definitely check that out. Really great way to start. And then if you get stuck, hopefully you're a PADT customer. You can reach out to us, and we can help get you unstuck. And if not, if you're not with us, whoever you get your Ansys support from, reach out to them and give them a call and ask for some help. And it's pretty cool capability. I really feel like when we started the company and people came to us with mixing problems, we kind of told them, just go out and build a test rig. It'd be easier because we really couldn't model it, right? And this is 20 years ago, right? I think it's safe to say that these days, before you build any piece of hardware to do mixing, you can certainly use Fluent and various other Ansys tools to figure out what that geometry needs to look like, and what the recipe needs to look like, and what the various input parameters can be, and do a lot of what ifs up front using those tools. Anything else you want to add to the topic that we didn't cover?
No, I mean, I think that's a great point, because a lot of folks, especially in pharmaceutical industry, will build a lab-sized, mixer and get the recipe, like you said, correctly.
Mm-hmm.
But how do you take that and make it into like production sized
scale?
Yeah. So scale that up to what you need it to, and that's a lot more expensive to do by trial and error. So being able to scale that up virtually, can save folks a lot of effort and funding.
I'm glad you brought up the scaling bit, because I'll tell a little story of a project and a manager who was told to scale up, and I'll not mention what kind of product it is, but it's applicable to what we're talking about today. It wasn't exactly mixing, but it was a chemical processing, and they had it working on the university bench, and he said it's a no-brainer to scale it up to production size, and he lost his job and the company went bankrupt, but because they tried to build this giant multi-million-dollar system without using simulation. They literally just applied a scale factor to everything and build a bigger version, and it's not the same thing as we know. So using simulation to check that out first is great. And and then something else I just thought of, because I just created a presentation on it, is this would probably be a good application for virtual prototyping, right? Not virtual, digital twin, right? So you can create your process, and if you want to tweak your process, you can try it out here rather than trying it out on the production line, right?
Yeah. And I think it is. I think you can kind of build yourself a little response surface and be able to, test out that way.
Yeah. So it's one of those where the digital twin's quite a buzzword right now, but I think this is a really great application for it, even if you're not designing something, right? That's where you could use simulation, is to go ahead and build yourself that virtual model that you can exercise, rather than messing up your production and getting it right that way. So cool. All right. Well, I really enjoyed the chat, and appreciate you educating me a little bit more on this topic. And I'm thinking about it more, and I am going to get a cup of coffee, and I am going to put some cream in it. But yeah, thanks a lot. And we'll hopefully talk soon about something else CFD-ish.
Oh, thanks for having me.
Thank you.
So I do believe strongly that I could model a margarita with this. I'm not sure that I could justify the cost and the expense, but pretty cool anyway. The funny thing is, we recorded this a couple days ago, and then out of the blue, we got an inquiry through our email for a local company that wanted us to do some mixing simulation for a civil engineering application, which was kind of cool. And I was thinking, did I put that? Did the podcast go out? But it was just happenstance that they got some mixing of some chemicals and some water that they want to model with Ansys Fluent. So we'll be able to put what we talked about in the podcast to practice. That's kind of fun. So let's talk about our commercial today. So once you've captured the mixing accurately, you may want to model your whole system. And that is where a tool called Flownex comes in.
FlowNex is a 1D thermal fluid solver that models complex systems with ease. PADT has been a distributor of FlowNex in North America for about 10 years, and FlowNex has been an Ansys partner for about the same amount of time. So it's a different program. It's not an Ansys program, but it is an Ansys partner. Our customers use it to model nuclear facilities, mines, secondary flow and turbine engines, combustors, medical devices, chemical processing equipment, all sorts of different applications. They're always coming up with new ways to model a system of fluids with thermals. Every month, we find a new application for this powerful tool, in fact. Oh, and not only are they an Ansys partner, you can connect Fluent to Ansys products in co-simulation to send boundary conditions back and forth, and also mechanical if you need to do thermal. It's also highly customizable. There is way too much to cover in this very short ad about all the different things FlowNex can use and why we like it so much. But if you're looking for a system-level thermal fluid tool, you can say that FlowNex is by far the best one out there. I feel really, really confident that it's the best one out there. So visit www.padtinc.com/FlowNex. That's FLOWNEX to learn more, or contact us at info@padtinc.com, and we would love to talk about this tool. It's our second favorite software tool in the world, right after Ansys. So speaking of Ansys, let's take a look at the stock. Taking a quick look at the ANSS page on Yahoo Finance, it looks like things closed Friday, which would have been the 9th, 9/9/2023, at $314.35, which is about 100 points higher than it was about a year ago, but still not at the all-time high, just over 400 in 2021. So year to date, it's up 30%, and it's up 21.46 over the past 12 months. So let's hope that trend continues. Not a lot of news in the Ansys world. It looks like they did acquire a company called, I'm going to screw this up, Copto, something like that. It is an IC design tool. So if you're familiar, Ansys has a whole line of tools that people use who design the actual chips, not chip packaging, which is kind of stuff that PADT does and a lot of our listeners do. But this is the actual designing the inside of the chip and using tools to verify that all the power and interference and all that stuff is working fine. So this is a new tool to go with the Apache tools that they acquired a few years ago. So check that out if you're in that area. But that's it. That's the only news they had. Not even any kind of public relations stuff. We didn't have any news on the PADT side as well. So I guess summer doldrums. On the Ansys blog side, we've got a couple things that I'd like to recommend. There are three articles I'd like to recommend. The first one is called Students Explore Biomedical Research with Ansys CFD. And we've mentioned these kind of blog posts in the past because I find modeling simulation, using simulation to model biomechanical things really, really cool and really hard. So if you can do that, if you can do a lung, if you can do a heart, you can kind of almost do anything. So I like to point those out, and it's also a great application to make the world a better place. The other is an article called Tapping into the World's Biggest Battery. And basically it's an article about a buoy that does wave energy extraction. So I thought that was pretty cool because it's got this fluid solid interaction and it's a great application. And they haven't really blogged it. It was on LinkedIn. Don't know if it's going to make the blog or not, but they released a new version, a new module or library. I never know what to call them in Python, in PyAnsys called PyDyna. So this is a tool that allows you to do pre-processing for LS-DYNA and allow you to get in there and do Python stuff while LS-DYNA is running. And if you've ever run LS-DYNA, you often find yourself stopping it, looking at the files, tweaking a few things. Well, you can do that programmatically with PyDyna, and again the pre-processing as well. Now you've been able to read the various output files from LS-DYNA for a little bit of time. I don't actually know when they added that into the core product for post-processing in PyAnsys, but that's there as well. So you can definitely do some cool stuff with PyAnsys around LS-DYNA, and we highly recommend that you check that out if you're an LS-DYNA user and kind of automate that. in many ways, LS-DYNA is kind of the most old school of the interfaces out there in the terms of running off of a batch file. In both Fluent and Ansys Mechanical, it's kind of hidden under the hood, but it's still there front and center in LS-DYNA. So being able to use Python programmatically is going to make some really nice enhancements there. So check that out. Also, I want to talk about, speaking of PyAnsys, we've had a couple of posts on the PADT blog since our last episode. I've put out 2 posts about using PyAnsys to make 3D results files. So basically extract the results from an Ansys Mechanical APDL result file, an RST or RTH file, and then output them in different formats that you can use for rendering or for 3D printing. And the biggest request for it is for 3D printing. So part 2 basically is still a text only. There's no user interface, and it adds in the ability to write out a WMF file. WRL file, which is the VRML format, which most 3D printers will read, so you can get your color contours that way. And then in part 3, I put a very clumsy user interface in front of it all so that you can actually enter in the numbers, like what result file you want, what substep, load step kind of stuff, where you want to put your output file, and then hit go and create the file. But then you can also tweak things, like maybe you're doing modal plots and you can just plot another mode. Pretty basic tool, but a little bit easier with the user interface. A great example of using PyAnsys as well. So those are the PyAnsys tutorial, exporting Ansys results in 3D file format, part 2 and 3. And then we have another post worth mentioning, actually probably more useful to a wider range of people. One of our IT support people, Courtney Harris, has published another blog article about how to share web licensing. So this is a new capability in Ansys, and that is instead of checking things out for your laptop or whatever, if you've got web access anywhere in the world, you can check out a license that way. And so Courtney goes through how to do that. We helped a couple customers get that up and running. So I highly recommend that if you're traveling and you don't want to have to VPN all the time in order to get access to your Ansys licenses. So that's a pretty cool tool. I think that's it. I've got another one coming out from Alex Gershon in a few days. Oh, I do have one more. Also on scripting, but a little bit different. It's about how to use the Python scripting that's built into Ansys Mechanical. So yes, you can use PyAnsys, which sits outside of Ansys Mechanical, or you can script within Ansys Mechanical using Ansys Mechanical scripting. And Christian Crowley did an article on the 8th, right after our last podcast came out, talking about that capability. So do check that out. And that is it for our blog posts. So what is up next on our agenda? Looking at my notes here. I'm a little bit here in the hotel room, a little bit discombobulated compared to where I am at office. So I apologize for that. But anyway, those are our blog posts that we put out, and we talked about the Ansys blog posts. Let's talk about upcoming events. Basically, we're doing a webinar on the 13th of September. That's next week on Wednesday, called Maxwell Updates in Ansys 2023 R2. So if you're a low-frequency electromagnetics person, check that out. Then related to what we were just talking about, 3D printing, we're going to be doing a webinar that's 3D printing related about what's the difference between 3D printing and CNC machining. So that's going to be on the 20th. And then we're going to be doing a Ansys Innovation Day in Katy, Texas. So if I think that's in the Houston area. If you're in the Houston area and you want to meet some of the Ansys PADT Ansys folks and learn a little about accelerating the energy transition through simulation. So we're going to be talking about all the different ways people are using simulation as the energy industry is going through these rapid changes. So do check that out. That's on the 21st. So again, if you're in Texas, we would love to see you there. Other stuff that's going on, PADT events-wise, those are 2 kind of Ansys related. We're going to be in Tempe doing the Experience Stratasys truck. So this is where Stratasys takes all their new printers, puts it in a truck, and drives around the country. So if you want to see these new printers in action, we're going to be doing that in Tempe on Tuesday the 12th. And then I already mentioned I'm going to be at the Sandia Science and Technology Park 25th anniversary celebration at the Nuclear Energy Museum here in Albuquerque on that's going to be the 12th as well. Then that Stratasys truck tour moves to Dallas on the 22nd and Houston on the 26th. I'll also be up in Colorado for the AIAA Rocky Mountain Section Technical Symposium 2023. It's the third time I've been to this event. It's really a lot of fun. It's very technical, a lot of papers presented by people doing different things. And I'm going to be on a panel about talking about propulsion, and I'll be, of course, talking about how we use simulation to do propulsion. So we're looking forward to that. Then I'll be back in Phoenix for the AZ Bio Awards on the 27th. PADT is the award sponsor for that. And then back up to Colorado on the 2nd for the Colorado Life Sciences Innovation Forum, and down in Tucson on October 18th for the Southern Arizona Tech Expo. And then the biggest event of the year, the most important event of the year that anybody that lives in Arizona or is trying to make a trip to Arizona and schedule around, is we're doing our annual Nerdtoberfest. This is PADT's annual open house that we do in October. It's going to be on the 25th, Wednesday the 25th this year. Everyone and anyone is invited. We basically fill the parking lot up with some fun stuff to do and some customer examples of things. And then we give tours inside PADT. We show you the lab. We show you the 3D printing areas and just kind of all over the place. And we'll have some Ansys demos as well, some new Ansys tools. So Nerdtoberfest is a lot of fun. We do have beer. We do have pop. We do have water. And we've also got some wonderful barbecue, including hot dogs, which we call Wurst. So do put that on your calendar. The official RSVP will go out on the 25th of September, a month ahead of time. But do a save the date. That's October 25th for PADT's annual Nerdtoberfest open house. And with that, I am going to finish up this recording here and then go out and explore Albuquerque a little bit more. I want to thank you all for listening as usual. Don't forget to subscribe to this podcast wherever you subscribe to podcasts, and also subscribe to our newsletter at www.padtinc.com/opt-in. Do spread the word. Let other folks know about the podcast. And as always, don't hesitate to reach out. Thank you for listening to the All Things Ansys podcast, episode 122. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.